Got a Jeep here, a 2015 Grand Cherokee, I think it was, with a customer complaint of it doing several things. Let's hit the button here. We've got a long crank. There we go, finally started up. And then we've got the little flashing light there. Okay, and check engine light. Service throttle, and this thing has no throttle, it won't move other than just around and idle. If you press the pedal here, you get nothing. It also says we got 100 pounds of oil pressure. That might be right, might be wrong, I don't know yet, but we definitely have no throttle. So let's get into this, see what's going on with it. So I need to go ahead and apologize. I won't have any like screen captures from the scan tool for this car because I'm an idiot and I left my Phoenix Smart at home this morning because last night I was pulling screen captures off of it for a video that I got recorded. And I just forgot to put it back in my van this morning. So on this Jeep, we're actually going to be using the Topdon Ultra Diag. I usually just use this for key stuff, but we'll use it on diagnosing this thing because I've actually already kind of looked at it once a little bit earlier today, and I know that I'm not going to need a scan tool a whole lot. So we're just going to go over here and do auto VIN, let it auto ID this thing. And there we go. Pull the VIN number and we'll hit confirm. And yep, 2015 Grand Cherokee. So let's just get an auto scan on this thing. So it's going through the modules one at a time, just scanning everything, and it's not super fast, but it's not slow. The Smart is definitely faster. But with this tool, this is actually all Topdon hardware, software. Everything in this is designed and done by Topdon, where, as most of you know, if I had a good place to set this thing and be able to record, as most of you know, the Phoenix Smart is launch-based software that Topdon leases, or whatever you want to call it, to use. So we got fault codes. Let me try to remember how to do a report. Oh, got the phone in my way so I can't really see. Now with this thing, I gotta remember how to change that. I'm sure there's a setting to be able to change that to where it defaults to miles. There's probably a lot of this that needs to be changed and reset up for being here in the US that I wouldn't really use. But anyways, we've got on the report here, we can do what kind of scan we got. We got pre, post, or diagnostic scan. We'll just say this is a diagnostic scan. If we wanted to rename it, we could, but we could put all kind of information in here if we needed to, some notes, and then you could also take some pictures of the vehicle if you wanted to. We'll shoot a picture of this real fast. I don't know how I'm gonna do this with my other hand. Maybe I'll just touch the screen. There we go. Added a picture to it. And we're going to hit confirm. There we go. All right. So we've got, what kind of codes do we got in here? Electronic throttle, unable to close, sensor reference voltage 1, circuit low, APP, circuit low, let's see, all kind of APP codes. Some of these I actually did because I was trying, when I was looking at this earlier, I was messing with the, what do they call it, the electronic throttle relearn thing, and it clears the learned values of the APP as well. We got crankshaft sensors is showing history, oil pressure showing as history. That's going to be about it. And look, there's our picture and the Bentley behind it. So we can hit save. And then I think after it saves, we can actually email this. Yeah, we can hit share and we can email this off to myself. There we go. Now I'll have this in my email. I think this QR code actually even brings it up once it's saved, I think. I think it goes to the cloud or something like that. But anyways, let's go into our engine control module. And we had some voltage codes for the 5-volt reference. So let's go into the data here for the throttle body and APP. Alright, so on our APP 1 and 2 volts, you can see APP 2 has a little bit of voltage. APP 1 has none. I'm going to press the throttle all the way to the floor. You can see APP 2 does come up, but APP 1 never does. Why is that? Well, that's because you've got one that needs to pull up to 5 volts, and it needs the 5 volt input to do that, whereas this one is actually being pulled down by ground, like it's actually fed like a 5 volt bias voltage, so it's needing the ground to pull that down, which it does. Let's go down to say, are they going to call it electronic throttle? No, it should be TPM or TPS. Yeah, TPS voltage. So same thing with the throttle position. You've got one that's pegged at 5 volts, one that's pegged at 0. This 5 volts is just the bias voltage from the ECM. And if I press the throttle, these don't move because, yeah, it can't move. So we need to get out and check this 5 volt. So I'm saying I don't really need the scan tool a whole lot. I've already seen all this data earlier today, so I kind of knew I had a 5 volt issue with this thing, and that's what we're going to try to find, is what's going on with our 5 volt circuit. Alright, so I got all data pulled up here, got a wiring diagram of the throttle body pulled up, and if I could do this without moving things, we got our 5 volt supply here that goes to the throttle body, and then we've also got a 5 volt supply here that goes to the APP sensor, which is the actual pedal. It shows these being 2 separate circuits in this diagram, but they may be on the same 5 volt rail that is inside the PCM. So I'm just going to check real fast here at the powertrain control module on this throttle body right here. And if I get this off of here where I can get this unplugged, I know from the diagram we need to be looking at pin 4, and it's a pink and yellow. So pin 4, pink and yellow, that one right there. I'll get the meter turned on here. we're just going to ground it to the ECM because the ECM actually has its own chassis ground, and we're just using a needle. This is not the correct size for these terminals, but I'm not jamming it in there. I'm just going to touch it to it. So you can see we're kind of lined up here with that pink wire, and on the meter we have no voltage. So that is our 5 volt that doesn't have 5 volts on it. And we should have one of these that's got 5 volts on it for biased. This one right here, that is the brown, it looks like a brown and pink wire. So that's got a 5 volt bias from the PCM. That's a sensor wire, I bet. So brown and orange, TP1. I think that's the one that was 5 volts. Let's see. Let's go back in to our data stream here. And sorry if it's a little echoey on the video. I'm actually borrowing a shop. This car lot just built this huge workshop. There's, I don't know how many bays. There's a ton of bays, and they've actually got this whole end section down here kind of set aside for me and another guy that come and diagnose some stuff for them a lot. So hopefully I can start using this to do some better recording, have a little more room here, a little cleaner, better lighting, things like that. But there is some echo in here, so I may have to figure something out for that. We'll see in the audio in this video. But anyways, back to this. Let's get down here to our TPS sensors. So TPS1, there we go, that 5 volts. That wire right there that we're in, and 5 volts. So that's a bias voltage, and I can actually pull that down with a test light. The joys of being in a small van. Where is my test light? There we go. So I can actually use this test light, and we can actually pull this down. It doesn't have to be a test light. You could actually just straight short this. It's not going to hurt the PCM, but there we go. 0, and our live data is now going to show 0. So that proves I'm on a bias voltage circuit from the PCM. I'll take all this out. So I need to figure out what's going on with this 5 volt rail inside this PCM. What is actually pulling it down? Is it shorted to ground, or do we just have a dead PCM? That's what we need to figure out. So now what I need to do is I need to determine if this is actually shorted to ground, or if the PCM is just not putting voltage out. And to do that, I'm just going to do a simple Alm test. And I can actually show you something pretty cool and why I don't really like Alm testing. So I'm going to show you a good Alm test, and then I'm going to break it to where it's not a good Alm test, and I want to know if you can tell me what the difference is. So right here's a good Alm test. I've already checked this, so I know. So I'm still connected to ground here. I can go to the jumper post ground. Doesn't really change anything, but just in case y'all want to know, we'll go there. Okay. So this is a good Alm test. All right. I'm going back to this pink and yellow wire, this pin number 4, and I'm just gonna. I'm not jamming the needle in here. I'm just touching the tip. Okay, so you can see we're shorted to ground. All right, that's definitely, this is a good test, or short to ground. Now let me show you how this ohm reading can actually mislead you. And we'll see if you guys will know why it's not right. All right, so we got the ignition turned off. Same wire. Look at our ohm reading now. 103 ohms. What is the spec that you usually see in service informations for checking wires short to ground? It's usually something in the neighborhood of like, is it less than 10, or you usually kind of have this thing where it'll say like, check from terminal whatever 4 to ground. Is the resistance over 10 ohms? Yes or no? No. Check for short to ground. If yes, it's going to tell you to continue on. But we've got 103 ohms. That doesn't seem like a short to ground, does it? But I just showed you that it was less than 1 ohm. What's going on here? Tell me down in the comments. Okay, so now what is actually happening here is there's actually some stray voltage on this circuit. It's very, very little. Okay. See, there's a tiny bit of voltage there. That is throwing off this. Look, now we're showing like kilo ohms. Was it showing kilo ohms the whole time? 100,000 ohms? I don't remember if that K was there a second ago or not, but still. This little bitty voltage, oh, now you see it go away. Now we're at 0. Let's see what our ohm is now. There we go. That is the module trying to put voltage out, and there's current on the circuit, and that's throwing off the ohm reading. That's why ohm tests are not really good. They're not, you have to know what you're doing to be able to trust them. Now, why did it just go away? Well, the module went to sleep. The module was still awake. Even though the ignition was off, the module was awake. So if I open the door, we can take and turn the switch on to make the PCM wake up. Okay, so ignition is off. And by the way, scan tool's probably not going to talk to it. See, no comm. But this thing is still awake. Yeah, there's no K there, but this module is awake. How do I know this is awake? If we go back to our voltage, okay, we got that tiny bit of voltage. Let's go back over here and see what our bias voltage was on that sensor wire. 5 volts. So, if the module is awake in any way, shape, or form, it kind of rules out ohm testing. That's why whenever y'all see me do ohm testing on like data networks and things like that, I almost always have the battery disconnected. That's about the only way to really trust ohm checks, is just remove the power source so you know there is no power source on the wire. Because if there's any current flowing, any voltage on it, it's going to throw off an ohm reading. So now that we know that, let's actually figure out why this thing is short to ground and a better way of actually testing this. All right, so now our PCM's asleep on our bias voltage. We've got 0. This is going to that sensor circuit. So let's go back over here. We're just going to go back to the 5 volt reference wire. You can see we've got 0. Let's go over to our ohms. And you can see 1 ohm. All right. So now how is a good way to actually test this for a short to ground? Well, I like to use my favorite little test light here. This is from GM. Actually, I think Kentmore is the people that build this. Don't remember. I think it's Kentmore. But anyway, this part number right here, J-35616-210. This is what GM calls a high impedance test light. This thing pulls very, very little current. When I test this thing, it's usually about 65 milliamps on a 12 volt circuit. So very low current. Module safe. I don't think there's anything in a module you could actually damage with this test light. So I've got one end of it connected here to battery positive, and if I touch it to ground, we can see that it lights up. So this is very low current. Now pay attention here. We've got this 1.4 ohms. I'm going to actually just touch this to my needle there and see if this lights up. If it's shorted to ground, this is going to light up. And it does. What happens to our ohm readings here? Kind of strange. Do y'all see how now current and voltage on a circuit can throw off your ohm readings? So, again, I don't really trust ohm readings a whole lot. I prefer using known methods like a test light. These actually test circuits. This will tell you bad, but it doesn't always tell you good. So just keep that in mind. So we've definitely got a short to ground. I want to know, is it in the PCM or in the harness? So what I'm actually going to do now, I know all these sensors are going to go to different circuits on the PCM. So I'm actually going to find everything and check it from the PCM. So let's try to figure this out. Using the diagram and the connector pin out, I knew that the 5 volt circuit here goes from the throttle body to connector C2 on pin 67. So just kind of looking over the connector views here, I knew which one this is. It's should say the color here, but I guess somebody's getting lazy. They stopped putting colors, but it is the brown connector. And then I proved out pin 67. And again, these are they're not in there. They're just touching the terminal. Don't stick needles in there. Use the terminals from the AES Wave kit, or if you're going to use a needle, just because it's actually just faster, just touch it. You don't have to jam it in there. So pink and yellow wire there, pin 67 there. I got resistance. I've got a circuit from there to there, so that proves this is my C2 connector. Now, what happened to my short to ground? Is it still there, or did it go away? Well, let's go back to my ground here. Oh well. Let's go back to my test light. So hook the power there and go right here. Nothing, no light bulb. If I go right here, if I can get my hand out of the way, no light bulb there either. So the problem is either something this is connected to inside, or if the 5 volt circuit from this connector is also tied in with the 5 volt that is on that connector, which is right here. So I need to figure out, is this side shorted to ground now? So about the best thing I could come up with is just actually unplugging both connectors and testing each 5 volt circuit for a short to ground. Now, since Chrysler doesn't really help you with just giving you a diagram of all the 5 volt circuits, you kind of have to work for it a little bit. But it's actually not too bad. Since there's only 2 connectors on the PCM, I can basically just use the search feature on Google or AllData or Windows, the Control F function. I'm on like C1 here, I just do the Control F, brings up the search function, and if I just type in 5 volts, it starts searching the document, and then I can actually just find all the pin numbers. So on C1 we've got pin 69, and you can see we've also got a second one up here, so if we hit the next arrow, pin 93. So I just wrote this down. So there's 4 5-volt circuits, 2 in each connector. So now I can actually just test those from the PCM for short to ground, and hopefully we'll find which circuit's pulling this down. If nothing is pulling it down, we kind of only got one other thing it could be. So let's see. So we can already rule out pin 67 on connector C2 because we've got OL right here and we're connected there and there. So if this was plugged up and that was plugged up, we know we've got a short to ground. We've already seen that. So unplugging both of these tells me that that circuit from there to here, there's nothing wrong with it. So on my notes here, we can check that off. And now we need to go to this pin 87. So I'm just basically, I know 67 is over here, so I can go to 73 and count off up to pin 87. Okay, so we're just going to look at our connector C2 here, and you want to make sure you know what your pins are. Make sure you orientate the connector how you see it in the connector view, and really just double check. You gotta make sure you're in the right thing. So this corner pin should be pin 96, and we need pin 87 because we've already checked 67. That's good. So we need to go from 96, go 95, 4, 3, 2, 1, 90, 89, 88, 87, and we've got OL on the meter. I think y'all can see that in the frame. So these two connectors are fine. There's nothing wrong with these. Let's double check and count from the opposite end. So 73, 4, 5, 6, 7, 8, 9, 80, 81, 2, 3, 4, 5, 6, and 87. So yeah, that's fine. We need to get back to our pin 67. We'll do that again. So this would be pin 72 because it's 72. 73 is this other corner. So 72, 1, 70, 69, 68, 67. That one is OL as well. So neither of the 5 volts on connector C2 are an issue. So now we need to look at connector C1, see if we can find anything wrong with it. I think I have y'all in the frame here. And same thing, we need to make sure we orientate the connector the way we see it in the view. So I know that pin 1, pin 24, 73, and 96. And we need to know pin 69 and pin 93. So for 96, 5, 4, and 3, we got OL on the meter, and then we've got 72, 71, 70, 69, and that one is also OL. So this is actually really starting to look like a bad PCM. The 5 volts is being pulled to ground. That's what it really is looking like. So this video is a little bit longer than I actually thought it was going to be, because I kind of went into a little bit more detail with some things with like the Alm test and things. So we're going to call this end of part 1 right here and pick up tomorrow with part 2, which is going to have the conclusion to this Jeep. And at this point in the video, we're kind of leaning towards an internal PCM issue. Okay, completely fine to think that's where we need to go based on our testing that we've got to at this point. But here's something really key you need to do if you're going to call a bad module. And I think Keith Perkins kind of coined this phrase or this idea of, okay, if you replace the module and the problem isn't fixed, what testing would you then do to determine what the problem is? And if you're at a point where you're calling a module, you need to think about this. What test would you do next if the module didn't fix the problem? And then you do those tests first before you replace the module. So part 2, that's where we're going to pick up.